Hi, this is Sushma working as Associate Professor in the Department of CSC, BVC Institute of Technology and Science. Now I am going to discuss about the introduction to cluster analysis. Okay, actually cluster analysis is a group of data objects based only on the information that is present in the data. That means information is nothing but the properties of the data objects. Here I'll be identifying the properties of the data objects and the relationship between the data objects. And this cluster analysis is used to group all such data objects having more similarities into one group, and all the data objects which are having less similarity, which are different from each other, into other groups. And here the greater the similarity within the group, that means the homogeneous data objects will be placed in a group, and the greater the difference between groups, the better or more distinct the clustering is. If you consider the example here we're going with an example. In this example we are given the 20 points and three different ways of dividing these 20 points into clusters. These 20 points are nothing but the data objects. 20 points are representing 20 different data objects, and the shapes of the markers indicate the cluster membership. If you identify the figure 8.1b, that means what is the figure B here, and figure D, there we are dividing the data into 2 and 6 parts. That means we are dividing the entire 20 data objects into 2 clusters and the 20 data objects into 6 clusters. And also we can divide the data objects into 4 clusters as shown in figure C here also. Okay, like this here we are able to illustrate that the definition of a cluster is very imprecise, and that the best definition depends only on the nature of the data and the desired results. These are the different ways how the same set of points can be clustered. Here the same set of original points, the same set of 20 points are being divided into either 2 clusters or 4 clusters or even 6 clusters. And the next thing what we are going to discuss here about is nothing but that what are the different types of clustering. An entire collection of clusters is commonly referred to as a clustering. That means earlier we have discussed about the 20 data objects which are divided into 2 clusters or 4 clusters or 6 clusters. The collection of all these clusters together, a collection of these 2 clusters or collection of 4 clusters or collection of 6 clusters together is nothing but a clustering. Here we are having different types of clusterings. And coming to the first, here we are having 3 types of clusterings: hierarchical versus partitional clustering, exclusive versus overlapping versus fuzzy clustering, complete versus partial clustering. And coming to the first one, which is nothing but hierarchical versus partial clustering. Hierarchy. As the name indicates, here you will be having different levels of hierarchy in the clustering. That means at the top level you will be having all the entire data objects, all the group of data objects will be present in the top level of clustering. And coming to the next level, these data objects will be divided into the next level of clustering based on some property. And here you can also call this a hierarchical clustering as nested clustering. Okay, and coming to the next one, that is nothing but unnested clustering. What do you mean by unnested clustering? That is nothing but your partial clustering. It is nothing but simply the division of the set of data objects into non-overlapping subsets. What do you mean by non-overlapping subsets? It is nothing but each data object is present in exactly one subset. Here, if you consider a data object, the data object cannot belong to more than one subset of cluster. It can belong only to a single subset of cluster. If you identify the previous example, here from figure B to D, all these clusters represent the partial types of clustering. technique they are following. And coming to the next one, that is exclusive versus overlapping versus fuzzy clustering. What do you mean by exclusive? As the name specifies, exclusive is nothing but each data object is assigned only to a single cluster. It exclusively belongs only to a particular cluster. A data object may not be present in more than one cluster. That means if I consider a data object X, this data object X will belong to either cluster 1 or cluster 2 or cluster 3, but not more than one cluster. It will be present in only one of the clusters, and hence you can call it as exclusive clustering. Coming to the next one, that is overlapping clustering. Overlapping is nothing but a non-exclusive clustering. What do you mean by non-exclusive clustering? It is used to reflect the fact that an object can simultaneously belong to more than one group or more than one class of objects. The clusters. What do you mean by that? Suppose if you consider a person working as a employee at a university, the same person can be a student enrolled as a student at the university also. That means the same person will be present in two different clusters. One is at a student cluster and the other one is as a employee cluster. Then such type of a data object, you can call it as an overlapping data objects. These two clusters, employee cluster and the student cluster, are overlapping with each other. Such type is called as overlapping clustering. And coming to the next one, that is fuzzy clustering. Here every data object belongs to every cluster. And how can you identify when how can it be possible that every data object belongs to every cluster? That means here these data objects will be having a membership weight. It can be either 0 and 1. A 0 indicates, then this membership weight can be in between 0 and 1. If it is 0, it indicates that it absolutely does not belongs to that particular cluster. If it is 1, then it absolutely belongs to that cluster. In other words, clusters are treated as fuzzy sets also. Okay, coming to the next type of clustering, that is complete versus partial clustering. What do you mean by complete versus partial clustering? It is nothing but in complete clustering, it assigns every object to a cluster. What do you mean by assigning every object to a cluster? That means if I am having 20 data objects and two clusters, these 20 data objects must and should be placed in both the data objects. That means 10 can be present in one data object and remaining 10 will be present in the other cluster, or 5 in one cluster and 15 in the other cluster. In whatever manner we divide, all these data objects must and should be belonging to the clusters. And coming to the partial cluster, this property is not followed. That means some data objects may be left without assigning them to any of the data clusters. Why like that? Some data objects may not be satisfying any of the properties of the clusters. Such data objects can be treated as noise or outliers, or they may be having some uninteresting background also. In such cases, you will be having the partial clustering, and these are the different types of clusterings what you are having. And coming to the definition of a cluster. What do you mean by a cluster? It is nothing but a group of objects where each object is having more similarity to every other object in the cluster than to any other object in the other cluster. That means if you consider two different objects in the same cluster, they will be having more similarities than the two different objects from two different clusters. That process is called as a cluster. And here we'll be discussing about what are the different types of clusters. Coming to the first one, that is well separated clusters. As we are having the definition of a cluster, okay, this well separated cluster is nothing but what the definition that we have discussed earlier, that is all the data objects in the same cluster will be having more similarities than the data objects that are present in the different clusters. Therefore, here you can say that two clusters are well separated when, if and only if, all the data objects within the same cluster are having more similarities than the data objects that are present in the other clusters. As this figure, if you identify this figure, this is a figure for a well separated cluster where each point is closer to all the points in the same cluster than to any other point in the other cluster. And coming to the next one, that is a prototype based cluster. What do you mean by a prototype? First of all, what is a prototype? A prototype is nothing but some set of rules that are to be followed. And what is the prototype that you are following in the cluster? Here the prototype that is to be followed in the cluster is nothing. The main thing is the centroid. Suppose if you are considering the continuous attribute values, if you are considering the continuous attribute values, then in such cases the centroid is nothing but the average of all the data points in the cluster, or the mean of all the data points in the cluster. If you consider the centroid as if it is nothing but like a categorical values, then the prototype is nothing but the median value. If it is a categorical value, what are categorical values? Like suppose if you consider the marital status, what are the different categories that you can have? Is married, unmarried, divorced, like that. Okay, continuous valued functions are nothing but if you consider the weather data. In weather data, if you consider the year value or the time value or the weather report, you can have all those values are continuous values. Based on the type of attribute values, here you are following the rule. If it is a continuous attribute value, or you are considering the rule as mean is considered as the centroid. If it is a categorical value, the rule to be followed is median, as considered as the centroid. Therefore, here we commonly refer to such type of as prototype based clusters, or also as center based clusters. Here in this picture you can see the center based clusters or prototype based clusters, where each point is closer to the centroid of its cluster than to the center of other cluster. When coming to the next one, that is graph based clustering. What is a graph? In general, a graph is nothing but a collection of nodes and the links between the nodes, or a collection of vertices and the links between the vertices. Here what are the nodes and vertices? Nodes are nothing but here the data objects, and the links represent the relationship among the data objects. Here the nodes are representing the data objects and the links are representing the relationship among the data objects. Suppose if there is a relationship between the two data objects, then it will be represented with the connection link between the data objects. If the data objects are having are not having any similarities between them, then they do not have any connection link between them. And here you can represent it with clearly in this picture. Here if you consider the first cluster, where you are having 8 data objects, where these 8 data objects are represented with the help of circles, that is nothing but the nodes, and the relationship between all these data objects is represented with the links. And in the second cluster also, you are having 8 data objects, and all these 8 data objects are represented with the nodes, and the relationship between them is represented with the links between them. And if you observe these two clusters, the distance between these two clusters is very high, because they are not having more similarities. And other type of graph based clusters are also possible, and such approach what you can have is nothing but a clique. What is a clique? A clique is nothing but a set of nodes in a graph that are completely connected to each other. That means here if you consider in cluster 1, these set of nodes in a graph, this is a graph, and these are the set of nodes in a graph which are completely connected with each other. And specifically, if we add connections between the data objects in the order of their distance from one another, a cluster is formed when a set of objects form a clique. And coming to the next one, that is nothing but a density based approach. What do you mean by density based cluster? A cluster is nothing but a dense region of data objects that is surrounded by a region of low density area. That means what do you mean by density? High density and low density. High density is nothing but more data objects will be placed in a cluster. When you are having more number of data objects placed in a cluster, you can call it as a high density area. And these high density area are grouped or collectively they are called as a cluster. If you observe in this figure, here I am having high density areas, 3 high density areas. One cluster is represented in the form of C, if you observe, and the other 2 clusters are represented with the circles, and the density within these 3 clusters are very high, and these 3 high dense areas are surrounded by a region where you are having a low dense area. Okay, and the 2 circular clusters are not merged here because the bridge between them fades into the noise. That means here you are having a distance between these 2 circular clusters, and the bridge is nothing but the difference between them is represented in the form of noise. And this figure you can here you can have a very clear idea about density based clusters, where the clusters are regions of high density separated by regions of low density. Thank you.